Mangalam, Mission Mangalam. Om Mangalam, Mission Mangalam. Om Mangalam, Mission Mangalam.
Hello, I am Venkateshwar Reddy. As a part of Group 9, we have selected a case study on ISRO's Mars Orbiter mission. The Mars Orbiter mission, informally called as Mangalyaan, is a Mars orbiter launched into the Earth's orbit on 5th November 2013 by Indian Space Research Organisation. The mission is a technology demonstrator project aiming to develop the technologies required for design, planning, management and operations of interplanetary missions. The main objectives of this mission are to explore the red planet, study the constituents of methane in the Martian's atmosphere, study the upper atmosphere of Mars, to study the morphology, topography and mineralogy, and to observe the dynamic changes in the atmosphere, effects of the solar wind and radiation.
Hi, my name is Ahmed. I will take you through the key equipment that were used in this project to accomplish the objectives. First, Lemon Alpha photometer. It's used to estimate and analyze the loss of water from Martian surface. Next, Mars Exospheric Natural Composition Analyzer. It's used for analyze natural composition. Next, Mars Color Camera. It's used for capturing imaging of Martian topography. Next, Mars Methane Sensor. It's used to detect the presence of methane in the Martian atmosphere. The last one, Thermal Infrared Imaging. A spectrometer. It's used to measure thermal emission and map the surface composition and mineralogy of Mars.
The three aspects of the portfolio of ISRO as a space agency are 1. Developing space technology, 2. Space science research, 3. Planetary exploration. These objectives were put in place to ensure the work of the agency had a direct impact on India and its population. The programme of projects the agency has undertaken since the 1960s is vast and involves the following areas: space vehicles, satellites, Earth observational orbits, education, training and helping other countries. In recent years, the agency has moved towards more planetary exploration, which led to the standalone projects to explore the Moon, Chandrayaan-1, and Mars, MARM-1 or Mangalyaan-1. When thinking about the MARM project within the P3M matrix, we can see that the project falls outside the usual remit of the programme of projects undertaken by ISRO, as they are usually related to space vehicles and satellites. But it falls within the portfolio of ISRO, as it directly fulfills one of the three strategic objectives and visions of ISRO, planetary exploration.
Hi, this is Prem Nuvala and I'm going to talk about the risk involved in this project. Technical performance risk. Electronic equipment damaged by interplanetary radiations. Cost risk. Overestimate or underestimation of time and cost for payloads. Programmatic risk. Failure to secure long-term political support. Schedule risk. Failure to meet the 2-week launch window. Liability risk. Spacecraft deorbits prematurely, causing damage over the debris footprint. Operational risk. Main engine not restarting after hibernation. Safety risk. Hazardous material release while fueling during ground operations. Supportability risk. Resource constraints like people, time, equipment, and supplies.
There were 5 main challenges of the Mars orbital mission, and these needed to be overcome for the mission to be successful. One of the first challenges was time. It became a race against time for the mission to be completed. The team were given 18 months to launch, so this meant there was no option to relaunch if the first mission failed. The second challenge was budget. The government of India gave the MARM project 450 crore rupees. This was 1/10 of the NASA Mars mission budget. But the project was very economical, and this was due to the approach taken by the team in regards to what information would be collected during the mission. It was so economical that excess funds were given back to the government of India. The third challenge was fuel. This was due to weight restrictions, as limited fuel could be carried. An elliptical orbit around Mars was chosen as fuel was limited. This changed the scope of the data collected, as traditionally a circular orbit would be used and different observations and data would be collected, but this would use more fuel. The fourth challenge was payloads. Due to financial constraints, the team had to reduce the number of payloads used on the mission. The payloads also needed to be small and compact, so they limited the size to 15 kg. The final main challenge of the Mars orbital mission was the challenge of unforeseen circumstances. Due to the limitations on fuel, time and budget, there was no scope for this. So if things were to go wrong during the launch, due to engine malfunction or any other reason, there would be no way to recover from this, and this would mean the mission would have failed. The Mars orbiter mission was successful due to being able to overcome these 5 main challenges. The team worked hard and concentrated on these main ones to be able to make this mission successful.
I'm Dhvanil, and I will take you through the key stakeholders that were involved in this project. As we know, stakeholder management and engagement is an important aspect in project management. The key stakeholders that were involved in this project were the Government of India. They were the project sponsors. Godrej Aerospace, they provided machinery that was critical for the launch. Larsen & Toubro, they provided motor casings and antennas. SANSA, they assisted in telemetry and satellite following. Satish Dhawan Space Center for the rocket dispatch and launch support. Space Application Center in Ahmedabad, they provided 2 out of 5 payloads. And importantly, NASA, they provided the communication and navigation support through their highly advanced technologies. The collaboration and engagement within these stakeholders ensured that this project was a success.
Let's discuss the key achievements of this project. This project made India the first Asian country to successfully launch a mission to Mars in the very first attempt and the 4th country in the world. This project was completed within $74 million. It was successful in completing the preliminary objectives like sending incredible photographs and scientific data of Mars. The planned duration of this mission was 6 months, but it's still operating over 3 years now. Even the MOM team won 2015 Space Pioneer Award, which was delivered by US-based National Space Society. It made India a forerunner in the interplanetary mission of the future.
As we have seen, ISRO was able to achieve a milestone through this project, but there was a lot of effort that went behind this project. So here is a short glimpse of what ISRO was able to do. Let's have a look.
The chances of this mission succeeding is less than 1%. Impossible.
It's impossible.
करना ही पड़ेगा। This is Rakesh Dhawan Mission Control initiating command for launch.
Go sir, go sir.
Go. एक्सपेरिमेंट नहीं करेंगे तो हमें अपने आप को साइंटिस्ट कहने का कोई अधिकार नहीं। पूरी दुनिया से कहो कॉपी दैट।
Finally, let's talk about the key learnings from this project. Visionary leadership, teamwork, and the quality of delivery and equipment. Visionary and effective leadership is essential in order to carry out humongous projects like these. The ISRO directors and project managers guided their teams effectively. Talking about teamwork, the project team and all the key stakeholders, they collaborated and ensured that the project was delivered on time and all the deadlines were met. Project teams and stakeholders collaborated from different countries and ensured that this project was a success. Talking about quality, since this project was developed on a stringent budget, it was extremely essential for the ISRO team to ensure that the quality wasn't compromised. The tools and machineries that were used in this project were developed in-house and were carefully examined, and the quality was excellent. Thank you.